Objective of proposed measurement system. What is the project? So this is a smart safe. It's meant to keep internal belongings safe via smart sensors, such as it'll be able to sense when the box is near heat exceeding a certain temperature. It'll be able to sense any impacts on the box inflicted by potential intruders, and it'll sense if the safe is rotated beyond particular angles, meaning that it's unstable and will lock. So what purpose does it serve? If any of these sensors above are triggered, a motor is activated that locks the safe. There will be an LED light to indicate if it's locked. There will be keys that are pressed that lock the safe. There will be a display that shows the keys being pressed and a buzzer to indicate whether the box has been successfully opened or not. And all of these will indicate usability and functionality for this pretty much smart sensor.
Hi, my name is Rehaz. Here I'm going to be talking about some of the sensing mechanisms of the sensors that we have selected and how will we be using it. That's in the next slide. So starting off with the step DC motor, we know that it rotates in steps, and this is especially useful for us since we can really precisely position it without using a feedback sensor, and this will be really useful in our project here. Secondly, we got the water level sensor, which will rely on the conductivity of water, and it will decrease the resistance across the two contacts that the sensor has. Based on that, we know what the water level will be. The two-colored LED, it's just a basic LED. It's got two parts to it. The way LED works is it just produces light by passing the electric current through it. The diode inside the LED will emit a photon, which makes it a light-emitting diode. For the 4x4 matrix keyboard, pretty basic. So it will short one of the row lines to one of the column lines. So for example, if you press button 1, column 1 and row 1 are shorted based on which member of the matrix is shorted. We can create an input for that. The touch sensor will activate when it's subject to touch based on how much pressure and force you add to it. Once you add pressure or force, it will act as a closed switch. And then when you remove your finger or the pressure or force, it will act as an open switch. So based on whether it's open or closed, we can tell what's happening with the touch sensor. The active buzzer has an oscillating source inside of it. So as you pass electricity through it, it will create a sound, a buzzing sound. So with just some basic DC voltage, you should be good on that one. Let's take a look at how we're going to be using these. So the step DC motor will most likely be operating the lock. So we can position that to move a lock back and forth. The flame sensor, of course, will sense fire. Water level sensor will sense flooding. Shock sensor is there for in case anybody's attempting to break our safe or throw it or kind of create any type of shock in there. The active buzzer will be an indicator as when the safe will unlock. The two-colored LED will be a visual indicator when the safe will lock or unlock. The 4x4 matrix keyboard is the user input to unlock the safe, so you'll be putting in a combination there. The touch sensor is used to confirm your combination, so you touch that once you have put in your combination already. The 4-digit 7-segment display will be there to indicate the combination you're typing in there. That way you know what you're putting in. And that's pretty much the basic sensor parts of our project.
The smart safe can be used for a number of different reasons in real life. For everyday customers, the smart safe can be used to save important documents and protect personal keepsakes and valuables. This can also be used in museums where high temperature and human error can destroy many artifacts and old documents. This can also be used for any institution that has valuable items that they would like to protect.